Hello class. Sorry I cannot be here today. I am gone for a conference, but we are moving on to day 7 in the homework. You should have your notes already open. We're going to be talking about trig ratios with right triangles. We're going to be talking about sine, cosine, and tangent. So trigonometric ratios are ratios that involve two sides of a right triangle. We have 3 ratios that we're going to be talking about. One of them is sine, S-I-N-E. The other one is cosine, C-O-S-I-N-E. And tangent, T-A-N-G-E-N-T. Alright, the thing that we're going to be talking about is sine, cosine, tangent. They are specific trig ratios, and our new favorite word that won't make any sense at the moment is SOHCAHTOA. SOHCAHTOA. S-O-H-C-A-H-T-O-A. And this word is going to help you to remember what sine, cosine, and tangent are. Sine is abbreviated S-I-N oftentimes, hence the S right there. It's going to be O over H, opposite over hypotenuse. Hence the O and the H. C is going to stand for cosine, and it's A over H, adjacent over hypotenuse, and I'll explain what those are in just a second. And then tangent, hence the T is O over A, opposite, O-P-P, over adjacent, A-D-J. Alright, here's what's going to happen. You're going to be looking at a specific angle. You'll be asked to find like sine of Z or sine of T, depending on the letter. That is your reference angle. The side across from the right angle, that's always your hypotenuse, and we've known that for a while. Now, the side across from the angle that you're looking at is the opposite. And then the side next to the angle, but not the hypotenuse, is the adjacent. Alright, and I'll show you what I mean in the example below. So sine of Z, we're talking about angle Z here. The hypotenuse is always the easiest to figure out, because it's across from the right angle. The side across from angle Z, so the side that doesn't touch angle Z, that is the opposite side. And then the side next to angle Z, that's the adjacent side. You're going to do sine of Z. So sine of Z, sine is opposite over hypotenuse. Opposite over hypotenuse. 9 over 41. You're going to write it as a fraction and then as a decimal. So now we're going to do 9 divided by 41 on our calculators. We will round to 4 numbers after the decimal. So it's 0.2195. And then you do cosine of Z. Cosine is adjacent over hypotenuse. Adjacent, 40 over 41. You can divide that on your calculator, 40 divided by 41, and you will get 0.9756. Tangent is opposite over adjacent, 9 over 40. You can divide that, and you will get 0.225. So that's sine of Z, cosine, and tangent of Z. Now, notice the next one is the letter T. So now we are no longer using angle Z, we are now using angle T, which is going to switch some of these sides. Hypotenuse will always be the hypotenuse. The opposite and the adjacent sides, though, those are going to switch depending on what angle we're talking about. So if we're talking about angle T, opposite side, the side that doesn't touch it, is the 40. And then the side next to angle T is the adjacent side. Once you have that, it's real simple. Sine of T is opposite over hypotenuse. 40 over 41. We did that up here. It's 0.9756. Cosine of T is adjacent over hypotenuse. 9 over 41. We did that up here, 0.2195. And then tangent of T is opposite over adjacent, 40 over 9. And 40 over 9, if you do that, you're going to get 4.4 repeating. So we'll put 4 fours after the decimal. Now number 2 is very similar to the first problem you're going to do on your assignment in a little bit. The big difference between this one and the one above is we have one side that we don't know. When we did this a long time ago, when we had a missing side of a right triangle, we did the Pythagorean theorem. A squared plus B squared equals C squared. Remember, the hypotenuse is C, and then the other two sides are the A and B. It doesn't matter which one's A and which one's B. So if I make this A and this is B, 29 has to be C, because that's the hypotenuse. So you're going to have to find the missing side before we can do what we did in the problem above. So we're going to do A squared, or X squared, plus 20 squared equals 29 squared. Alright, you can do 20 times 20, you'll get 400. You can do 29 times 29, and you're going to get, let's see, 841. From there, you're going to get x squared by itself. You subtract 400, you get x squared equals 441. To get rid of the 441, you're going to square root. So on your calculator, here's a picture of the calculator. Square root's right here. You're going to hit square root 441. And that should give you the answer. So if you square root 441, you're going to get 21. So this equals 21. Once you have that, now you can find the sine, cos, tangent of all the stuff that you need. So the sine of w, cosine of w, we're dealing with w first. Alright, this side is obviously the hypotenuse. And then the other two sides are going to be my opposite and my adjacent. The opposite side is the side that doesn't touch angle w. So this is going to be my opposite side, not adjacent, opposite. And then 20 is the adjacent side. And then you can find sine of w, opposite over hypotenuse, 21 over 29. And then you can divide it on your calculator. You're going to get 0.7241. Cosine of w, adjacent over hypotenuse. So this is where your SOHCAHTOA is going to help remind you of what goes on top of what. Cosine, adjacent over hypotenuse, 20 over 29. And you can divide that on your calculator. You get 0.6897. And then tangent, opposite over adjacent, 21 over 20. And you will get 1.05. Now when you do B, it's going to change your reference angle. So your opposite and your adjacent sides are going to swap a little bit. Hypotenuse is still 29. Opposite side from angle B, the side that doesn't touch it, is 20 now. And the adjacent side will now be 21. And then you can go from there. So sine of B, opposite, 20 over 29. We did that up here. You get 0.6897. Cosine of B is adjacent over hypotenuse, 21 over 29. We did that up here. We got 0.7241. And then tangent of B is 20 over 21. 20 over 21, divide that out, you get 0.9524. And that's how you will do that first problem on your assignment. On the back, these ones are pretty quick and pretty easy. You're just typing stuff on your calculator. It says to make sure your mode is set to degree. If you have one of my green calculators, you're already set. We will be rounding to 4 decimal places, the nearest 10,000th. Sine of 15. On your calculator, you will see the calculator button sine, cos, tangent right here. When it says sine of 15, you're going to hit sine and then 15 equals. And then you round. Real simple. Cosine 70 equals. And then you round. Tangent 40 equals. And then you round. You're all set. So these ones are pretty simple. If you type sine of 15, you're going to get 0.2588. If you round to 4 numbers after the decimal. Cosine 70, you just hit cos 70. You get 0.3420. And then tan 40, hit that. And you get 0.8391. Alright, the ones that are a little bit different are these ones down here. Notice that it's sine of a letter, cosine of a letter, tangent of a letter. Whenever you have sine of a letter, cosine of a letter, or tangent of a letter, what you're going to do on your calculator is, on the green calculator anyways, you're going to hit shift, and then you're going to hit either sine, cosine, or tangent, depending on which one it is, and then you're going to type the number. So like for this one, you have sine of x equals 0.7883. On your calculator, you're going to hit shift, which is here, sine, and then 0.7883 equals. For the next one, you'll do shift cosine, 0.6694 equals. And then the last one, you'll do shift tangent, 0.0524 equals. So let's do that. You do shift sine, so shift sine, 0.7833 equals. You round to the nearest degree. So if you round to the nearest degree, you get like 51.5, so that's 52 degrees. So no crazy decimals with this one. Second, you'll do shift cos 0.6694 equals. You get 47.9, which is 48 degrees. And then you do shift tan 0.0524 equals. You get 2.99, which is 3 degrees. So that's how you'll do those. And then the last one is just which trig function would you use to find the missing angle. So what you'll do is you'll look at the angle that you have, D's for all of these. 13 is your hypotenuse, and 8 is your adjacent side. It's right next to it. So we're trying to figure out between, let's write SOHCAHTOA here. SOHCAHTOA. We want to know, are we going to use sine, cosine, or tangent if we have the adjacent and the hypotenuse side? So we're looking for the trig function, either sine, cosine, or tangent, that has a and h with it. Well, sine has o and h, so that's not it. Cosine has a and h. That's the one I have, so I would write cosine. For b, I have this angle. 5 is my opposite. 2 is my adjacent. I have a and o. So I need to figure out which one has a and o. Well, sine doesn't. Cosine doesn't. Tangent has a and o, so I would put tangent. And then for this one, we have angle D is here. This is my opposite side, and this is my hypotenuse. O and H. So S has O and H, so it is sine. So you're just using this to figure out which ones you have, opposite, adjacent, hypotenuse, and then which trig function it goes with. Alright, so like D here, this is my opposite side, this is my hypotenuse. O and H, I just did one like that, it's sine. The next one, same thing. You got adjacent is here, hypotenuse is here, A and H. Well, it's not sine. C has A and H. C is cosine. And then the last one, we have angle D is here. This is my adjacent side because it's right next to it, but not the hypotenuse. And then this is my opposite side. O and A would be tangent. And then you're all set. So good luck. I will be here on Friday, I promise. And we'll see how things go. Okay? Good luck!